So we are rotating around the line x equals 7. We did start this problem yesterday, but it's a pretty tough one. So we've got some things to look at. 1, 2, 3, 4, 5, 6, 7. So I'm rotating around that line. And I can't really even show you the other half, but it's over here, right? Everyone kind of know what I mean by that. It runs off the board there. And so we have, is there a gap?
I was kind of confused on that when I started the homework.
Mm-hmm.
Like, when you go to like flip it over a line, does it flip or does it like rotate?
Well, it rotates, but the two-dimensional image looks like a reflection. If I were to rotate something 180 degrees, it looks like a reflection. But it's really taking that shape and swinging it around, so you're getting a three-dimensional image. Does that make sense? But for drawing purposes, especially for those of us who are artistically challenged, we can kind of do a reflection to get an idea of what the picture is. But this is coming out like this, and then back behind here like this. That's the outside, the inside, and then we have the outside that comes like this. Makes sense. So this is definitely a washer problem, and it's definitely dy because we're cutting perpendicular circles to the y-axis. And we decided yesterday that our start was, what did we say, 0 to 4? R squared minus R squared dy. However, the problem, what if I move down to this part and look at the outside circle? Bigger, which is okay. We'll look. And then the inside circles, I'm going to still draw in blue. Okay, let's talk about the green outside circle, and then let's talk about the red outside circle. The green outside circle, what's the edge of the curve? What curve am I on the green outside circle? I'm on that x squared curve. Everyone agree? What curve am I on the red outside circle? Uh-oh. Why uh-oh? That's different. And so I can't just use one integral to cover the outside circle. So this is going to have to actually be, scratch the 0 to 4, actually have to break this into two integrals. I need more room than that.
When you did 2 to 4 though, how did you use the x?
The y. And do you know why I would use y?
It's dy.
Mm-hmm. Would you agree that right here is where I need to switch from one curve to the other one? What is that y value? 1. And if you're unsure, you can go look at an intersection. It would be the y value of the intersection, not the x value. 0 to 1. The outside circle on that piece is the green circle. So now let's talk about the radius of the green circle. What is the radius of the green circle? Maybe. Now it will change because it'll move along this edge, right? So I can't just say 8.
8 minus that.
Close. 7. You know why 7? It's this line is x equals 7. 7 minus this edge of the parabola. I need to time out really quick. The parabola was y equals x squared. Was that right? So what is the, remember I'm dy, plus or minus the square root of y? Which one is the left-hand side of the parabola? The negative? Everyone agree with that? So I have 7 minus negative square root of y, which you could write plus, but I just wanted to write it down the whole way. Minus the blue circle, which is 7 minus what? Positive square root of y, 'cause it's just the other side of the parabola. So that is plus pi times the integral from 1 to 4. So I have found, if you could see this picture, you see how there's kind of a poked out point here? I have found the volume up to that point, all the volume below here. So now I'm finding the volume above that from this straight line up. So I have the red circle, 7 minus the line. Everyone agree 7 minus the line? What was the line? So x would be, make sure you do put parentheses there or distribute the negative. Minus blue circle, I don't have to think because isn't it the same as the other blue circle? That's normal that the circle doesn't change. So this was kind of a weird problem in that it had to do 2 pieces. So is it important to imagine your circle moving and not imagine it stationary? We need to look at the circles all the way up the image or all the way across the image. All right, so let's look at this one. I'm revolving around the line x equals -5. Do your pictures have to be great? No. Remember, use the image that they drew as far as finding values. Am I going to have to do 2 separate integrals again? Let's look. Circles down here, inside circles. Oops. Would you agree the inside circles have to do with the parabola and going to there? Oops. Inside circles have to do with the parabola. And outside circles also have to do with the parabola on the bottom. However, on the top, because this is our region here, right? Sorry. Come on, computer.
Does that line be to the x plus 2 line or to the edge of the parabola?
On this one, it would be the edge of the parabola because you go all the way to your region, and the green shaded is my region. So this little triangle here is not part of the region that I'm rotating. In fact, you could not draw that part, those lines, because they're not part of the region. As I move up, the inside has to do with the line. Agree?
That's an inside line.
The red one is the inside.
Yeah, that's part of the shape.
And then the outside still is parabola.
So it's not all changes.
Mm-hmm. I'm not very good with this pen, am I? You're getting to see our artistic challenges. So this time the outside circle is the same on both the bottom and the top, but the inside circle is different as I move up. So I have the integral. Don't forget your pi. The outside circle, I would use this line as my left and the parabola as my right, or sorry, on the outside circle. I've got to go from here up to here, where the inside and outside are both parabolas. You see how the inside and outside of that image are both on the parabola? But then after that point, the inside and outside change to where it's the line on the left and the parabola on the right. If you were just integrating area, if you would have to break it up to integrate area, then you'll have to break it up to do volume. You see how if you did right minus left, how that would be different? Okay, so the outside circle is the blue one, and it goes to the edge of this parabola, which is the square root of y, minus -5. Purple circle next, minus the inside of that parabola, this piece right here, negative square root of y minus -5, plus outside circle stays the same, would you agree? But the inside circle is now line minus -5. What was the line? Y minus 2. Did she answer your question?
No, I was wondering when x equals 7, it was 7 minus square root of y. Why is it like that?
It's the right minus the left. And so the 7 was to the right of the image. The -5 is to the left of the image. Now, that being said, I would like you to do it right because it's good practice for area. However, if you did -5 minus square root of y, and then you squared it, because of the square in this particular formula, if you happen to do it backwards, it will take care of itself because of the square. Now, what won't take care of itself is if you do the little circle minus the big circle. You know what I mean by that? But inside here, if you wrote that backwards, you actually would get away with it. Does that make sense? Why you would get away with it? Because of the square. Find the volume of the solid if the region enclosed by y equals 2x, cosine of x in the x-axis, is rotated around the line y equals 4. So y equals 2x. Cosine of x, would you agree cosine of x starts at 1? and the x-axis. So, step one, hardest part, what region am I rotating? Actually, this is, yeah, has to be this one, right? The only region enclosed by those three things. And we're going to rotate that region around the line y equals 4. I'm going to erase the rest of this line just so it's not in my picture, now that I have my region. So I'm going to rotate this region around. Oops. Okay. And I do want to kind of point out, if I were to do the area of this with respect to x, would you agree that I'm going to have to break it up? If I do the area with respect to x, I would have to break it up. Because on the left I have the line and on the right I have the cosine. So if I have to break it up with respect to x for area, and I'm doing volume with respect to x, I'm probably going to have to break it up as well. So this is another example. And so I'm going to draw some circles. Now, outside circles. Would you agree that the outside circle, and notice I'm not even drawing the other piece of the image, so if you're artistically challenged like I am, you can get away with that. The outside image, the outside radius here, no matter where I move that green circle along this curve, isn't it always the same? In fact, it's always 4 units. Everyone agree? Outside radius is always 4 units. No matter where I move along this, the outside radius is always 4. Okay. So this green circle is my outside radius. If I swing this guy around, the outside piece would be this bottom line here. So no matter where the green circle falls, the outside radius is 4 units because it's from the x-axis up to the line y equals 4 is the radius of this green circle. That makes sense? No matter where I put it, that's where it is. However, if I draw an inside circle, let's use purple. Right here, I'm on the cosine graph. Right here, that radius is on the cosine graph. But then over here, it's on the y equals 2x graph. Does this movable image kind of help y'all to see that break, where those circles break? So we have 2 pieces on this one. We have an inside circle on the left, and we have a different inside circle on the right. So, let's start. It is washers. And we are doing dx. My first piece, and I'll go find an intersection in a minute. You agree I'm probably going to need a calculator to do the intersection. Four squared. And in fact, I could go ahead and do the second piece. And it's also going to have a 4 squared at the beginning. Do we agree with that? The outside circle is the same on both pieces. Minus. Where am I cutting? What is this circle perpendicular to? But we should have asked that question earlier, so I'm glad you brought that up. The inside circle. If I am on the left, would you agree the inside radius is 4 minus the line? 4 minus the line. So my inside radius is 4 minus 2x. But when I move that circle over to the other part of the curve, it's 4 minus cosine of x. Now's the calculator part of this question. Why do I know that I need a calculator? Cosine and x, 2x, I can't find the intersections of those by hand. I don't know when cosine equals 2x. It's not a unit circle question. So I know this must be a calculator question. Which also means, did I have to graph it by hand? No. I could have graphed it in the calculator. So y equals, that's what we're going to need a calculator to do that. Cosine of 2x, no, cosine of x, sorry, and 2x. You may want to zoom in on your graph. And I just see the image. So again, you would not have had to graph this image by hand because we know this is in fact a calculator problem. You see our region here. And remember, we're rotating around the line y equals 4. But what I really need to know are the intersections. First, I need to know this intersection here. I'm pretty confident that 2x crosses the x-axis at 0, so that you probably know without doing any work. Second, trace 5, find the intersection, and I get 0.450 for that x value. I'm going to take that x value, I'm going to go to my home screen, and I'm going to store it. I'm going to type x store as a. So I'm going to store that value so that I get accurate to 3 decimal places. I'm going to go back to the y equals. I can either go find this intersection and store it, which since you have a calculator, you're welcome to. You would need to type y equals 0 in or find the 0. Or you could just know that cosine crosses the x-axis at pi over 2. And so you can either do that by hand or in the calculator, it doesn't matter. So I'm going to put up, if this were open response in my problem, I would put A is approximately what was it, 405?
No,
I got one.
4.5.
Sorry. But I'm letting the AP reader know I'm not just using those 3 decimals. So I'm going to go from 0 to A, and then from A to pi over 2. Again, if you had stored pi over 2 and called it B, they'd give it to you. Since you have a calculator, you can use it if you didn't know that. And then, just for fun, since we haven't typed very many of these in the calculator, I want to show you how to do that. Pi times the integral from 0 to A, open parentheses, no, I need to open parentheses yet. 4 squared minus open parentheses, was it 4 minus 2x on the first one? Dx plus pi, do not forget your pi, you could do it later, but just don't forget it, from A to pi over 2 of 4 squared minus, it was 4 minus cosine of x on the second one. Am I correct? Close parentheses squared dx. And so 17.763. This is as hard as they could ever get. They're usually not this hard, but this is as bad as they could get. Those of you who go on to take Cal 2, there is actually an easier way to do some of these, and it's with what's called cylindrical shells, but you can learn that in Cal 2. Some of the ones that are very hard with discs and washers can be done a little easier with cylindrical shells. Okay, do I need to go back? You sure? Okay. I want to do just 2 AP practice problems, and then we will be done for the day. These have nothing to do with discs and washers, just some things I thought would be good to review. If the integral from 0 to k of this is 18, then what is k? So try that one.
So looking at this image, the first piece here, if I'm just going to circle here to here from the x. And so this is 0 and this is where so I do that piece first. That volume. And then I add this set. Could you add them either way? Normally we go left to right, so probably do that because yeah, if you're swinging around and you're out here, it's here, it's all fine. Then after that intersection, you see that switch there. These should take you around 2 minutes each. Multiple choice AP problems, you have around 2 minutes a problem on the APs. More on some, less on others. Okay. On the first one, what'd you do first? Anti-differentiate. 2 and k are both just numbers. So you would have 2k times x 1/2 x squared. Does everyone agree with that? Raise the power and divide by the new power. Yes, no, maybe. Minus 1/3 x cubed from 0 to k. The 2's here just cancel. So I get k cubed minus 1/3 k cubed minus 0. K cubed minus 1/3 K cubed will equal 18. What's 1 minus 1/3? 2/3 K cubed equals 18. Multiply by 3/2 or divide by 2/3, either way. And that gives me 12, right? No. 27, that's better. 18 divided by 2 is 9. 9 times 3 is 27. K cubed is 27, and then cube root both sides, I get 3. Any questions about that one? Okay, let's look at the next one. If the function is defined by that, the square root of x cubed plus 2, and g is an antiderivative of f, such that g of 3 is 5, then what is g of 1? How am I going to have to do that one? What's my first thought? Find the antiderivative. And you look at that and quickly go, nope, can't do that, because it's not a u substitution problem, so I'm in trouble. I can't break up a square root with a plus in between. So I can't do this by hand. Look at the answers. Do they look like by hand answers? So when I can't find an antiderivative, what formula comes in handy? I can't actually find it. Start point, end point thing. You know what I'm talking about? Now, if you've forgotten that, just use the fundamental theorem of calculus. The integral of f of x dx from 1 to 3, won't that equal g of 3 minus g of 1? Right? So if you forget it, okay, who cares? G of 3 is 5. Put this integral in the calculator. Subtract 5, divide by -1, right? Do that for me. The actual formula, if you like to use it, and I'm okay if you don't like to use it, as long as you can use this, I'm okay with that. But the actual formula is, if I want to find g of 1, that's actually my end point. So g of 1 equals the start point, and that's weird that g of 3 is the start point, but plus the integral from 3 to 1. And those are backwards, but they're backwards on purpose because the start or the end point was 1. This is the formula, which takes care of the negative and everything in it. So if you like the formula, use it. If you don't like the formula, use the fundamental theorem. We know you have this memorized because I made you on the integral test and the gateway test. What do we get? I think it's B, but I could be wrong. E? Okay, E sounds good. E? Everyone got E? Any questions about that one? Okay. These are the problems that I'm going to assign on AP packet number 7. I want to grade these 4 on Monday and these 4 on Tuesday. These are the only ones I'm actually assigning, but any of them on the packet will help you review for your test. Your test is next Wednesday, Thursday. Okay.
On that problem, I got -1.5.
You did? For some reason, that's what I had in my head. Let's try. I don't know. 5 plus the integral.
Oh, I know what this is.
It is B? Okay.
I put 1 to 3.
1 to 3. Okay. If you're just typing it in without doing the fundamental theorem, you have to do the 3 to the 1. It is B. Okay. 3 to 1, not 1 to 3. If you're doing the formula.
Not at the top.
The top one. And so G of 3 is 5. So did you subtract it over?
Yeah.
We did the integral from...
No, I think I added it.
Ah. Do you see why you would subtract it? Because if this is 5...
Then I got a negative, or I got positive.
Okay, but then you divide by -1 because G of 1 is negative here. So this one requires more work, but it's probably more likely that you have it memorized. For some reason I thought it was B, but I don't know why I thought that. Okay, any questions about what's coming up? Tomorrow we will have a work day, so you can ask questions tomorrow. Today we do have 10 more minutes. We're going to grade area and volumes of solids. Tomorrow we will grade discs and washers. Maybe at the end of the hour tomorrow, discs and washers. So if you do have any questions, we can ask. How was today? Pretty nasty ones today. Good.